Nothing? No questions yet? Okay, if no, you know, guys, the problem is that whenever you do not have any questions, it seems that I have questions to ask you. And as usual, I have a question to ask you, and as a result, let me put these papers aside. Let me put the table for that. We have a nice function for us. It goes on top. Okay, guys, today we are gonna do two very exciting things. The first thing is that we spend half of the class in order to review some practical aspects of the sum of the functions that we learned. And after that, we do some new lesson, new topics to cover. Let me grab my. Okay. How's everybody feeling now? Excited about the day?
Great.
Okay, let's start the very first example of the day. The very first example, I also had it on my previous class, and they said that they loved it because it is so much practical stuff. Guys, there is one discipline in university. If you happen to study mechanical engineering or any other related fields in the science, there is a course they call that fluid mechanics. In the fluid mechanics, they describe, I should say, the velocity of a fluid by this equation. As I'm just writing as an example. This example shows that, for example, the velocity of a fluid, it's going to be modeled as gamma 1 times V1, this is V velocity, sine alpha equals to gamma 2 V2 of the sine alpha minus beta. This equation, this is, you see that, this is, I think, for the first time that you are using trigonometric identities in order to describe something. Because, listen, sometimes the purpose of the math is very simple, to describe the thing which happens around you. And in fluid mechanics, I think that's the first time you see that the trigonometric function, you are not working with them in an abstract form that you haven't seen them before. You see them in a context, and that context is in fluid mechanics. Imagine that you have a fluid. It means, for example, something which moves around. Who has done science class? Who said that he has done science class?
Me.
Gloria? Gloria,
Yes.
in your science class, you have learned that the material, they exist in how many shapes?
No.
How about, who knows that answer? A material exists in universe in 3 different shapes. This is 4, but we do not include plasma at the basic level. It's 3 level. It's either solid, it's either fluid, or it's either gas. Everyone has heard of that, huh?
Yes.
Yes? Then in the context of the fluid, when the fluid is become dynamic, we are not going to talk about that. They represent its evolution by this formula. And I think that's the first time that you are going to see this simple trigonometric ratio like the sine of the alpha or sine of the beta. It comes within a context which describes the dynamics of a fluid in nature. It's exciting, huh? Everyone is excited now to see that context? I'm very excited. I hope that you are the same. Now, I'm just going to ask you as a homework, not a homework, we do it today. Imagine that if I say that in the fluid which I have, the gamma 1, they call that the gamma, they call that viscosity. We do not care. Times the velocity at point 1 equals gamma 2 at plus times velocity 2. These two are going to be the same. Now, I'm going to ask you, please, guys, as the future scientists, please show that the identity can be transferred into a new format, that the cosine of the beta minus cotangent of the alpha times sine beta is going to be equal to 1. Let me put that inside, I should say, circle. I'm very excited about this exercise because, guys, this is the first time, honestly, we are looking at a trigonometric ratio in a context that describes a phenomenon in nature. And now this is a fluid. It's a very exciting thing, honestly. Now we want to prove this identity. It's very easy. It takes only 2 minutes. Well, let's see. Okay. Everyone knows what's going to happen? We have this equation in fluid mechanics. We assume that if gamma 1 V1 equals gamma 2 V2, this relationship changes to this one. It's pure math now based on the things which you have learned last week. Everyone is clear about the task? Say yes. Say your name, guys, if you're okay with it.
Rose.
Yes.
I heard Rose. I heard Gloria. Who else?
Yes.
And Philip. How about Ferris? Ferris. Ferris is gone. Okay, guys. I think 2 minutes should be fine. Give it a look. Give it a thought for 2 minutes and feel very excited because that's the first time you see this ratio in a good context. 2 minutes, I think, should be fine then. Give it your best. Give your shot. Guys, are you done or do you need any help? Who is done? Rose, Gloria, Philip, Ferris.
Not yet.
Okay. But Rose, are you enjoying this exercise? Do you like it?
This exercise?
That's right.
Yes.
So beautiful, huh?
Yes.
I like it myself. It's in a good context. Okay. Should I start or do you need more time? Do you need 1 more minute?
Yes.
Okay. 1 or 2 more minutes then. Beautiful day. Okay, shall I start?
Yes.
Okay. Who is done? Who finished that exercise? No one?
No.
You didn't finish it, Rose, huh?
Not yet.
How about Gloria, Philip, and Ferris?
No.
Okay. Do you think you can finish it if you have 1 more minute or no?
No.
No. Okay. Then I'm going to start it myself. You please help me, okay, at every step. Sure?
Yes. Yes.
Sure.
Okay, let's see. But you see clearly what is on the paper, huh? The color is fine, the light is fine, huh?
Yes.
Yes. Okay. Guys, the first thing is that I'm going to start from the first equation. I'm going to start from the first equation and I intend to go to this one. If I start from the first equation, the first assumption which is given is that these coefficients, that gamma 1 V1 should be equal to gamma 2 V2. What does it mean? It means that if I come here and write this equation with this assumption, I should get what? I should get, let me use a different color for it. I should get gamma 1. You see this color? V1 times sine alpha should equal to gamma 2, V2, which I made a mistake because these two should be equal. Then let me write it as 1 times sine of alpha minus beta. Give me a second. Oh, I do not have a corrector. Then, guys, look at that. These are ones. Okay. Guys, look at that. If gamma 1 V1 equals to gamma 2 V2, means both of them are going to be the same quantity, huh? If this is 4, for example, this is also 4. If this is 1 million, this is also 1 million, correct? Then I can just simply remove them from the equation. Then it means that I end up only with this question, that the sine of alpha equals to the sine of alpha minus beta, correct? So far, so good. Everyone is clear so far?
Yes.
Yes?
Yes.
How about Gloria, Philip, and Ferris?
Yes.
Awesome. Then what happens there is that I end up with this identity that the sine of alpha is equal to the sine of alpha minus beta. Okay. And now I'm at this stage. What's going to happen now? I'm just going to, I see this one on the right side, sine of alpha minus beta. But you remember that from the last week lecture, we said that the sine of alpha plus or minus beta equals to sine alpha cosine beta plus or minus cosine alpha sine beta. Do you remember it from the last week?
Yes.
And as a result, what I'm going to do, I'm going to expand the right side of my identity using, of my question, using this identity. Which it means what? Which it means that I have the sine alpha written on the left side should equal to, I expand this one. What does it show up? As sine alpha cosine beta. There is a minus sign in between, then becomes minus cosine alpha sine beta. Correct? Everyone is good so far?
Yes.
No questions?
No.
No. Okay. Guys, how about Philip and Ferris and Gloria? Everyone is doing great. Yes? Okay.
Yes.
Now, guys, take a closer look. I have sine alpha on the right, and I have two terms on the left. I have sine alpha on the left, and I have two terms which involves also alpha in it. Then what happens? Can I divide both sides to the sine alpha? As long as sine alpha, I suppose, is not be equal to 0. Can I do that? Yes. Then I say that I divide the equation which I have there. I'm going to use this color, and I say I divide both sides by sine alpha. It becomes sine alpha there, and also sine alpha there. And I know that for sure that sine alpha is not 0. Because if it becomes 0, that's a problem. Then the denominator is 0 and the ratio is not defined. Okay. Then if that happens, what's going to happen now from this identity? I'm going to divide both sides by the sine alpha to see what happens. On the left side, I have sine alpha divided by sine alpha. What do I get up? What do I end up with? It becomes 1, right? Sine alpha divided by the same thing, by itself. It's like a divided by a. Becomes how much? Becomes 1, correct? Then becomes what? To the right side. To the right side, let me write it in more details in case if you have some problems with it. This one has to be divided in both sides. I have sine alpha, cosine beta divided by the sine alpha, and I have minus sine alpha times cosine alpha sine beta. And you see the minus sign, huh? You see that, guys?
Yes.
Okay, you see that these are the same thing. If you take the common denominator from both sides, you end up actually with the same thing, which is very easy to show that. You take the common denominator from these two expressions, sine alpha is there, and I have the numerator is built up by itself. But then it becomes what? Guys, with this one, you have to decide which one, because they are multiplied, they can be removed. Okay, let's see what do I need. Let's take a different color. Guys, look at this expression. I have sine alpha cosine beta divided by sine alpha. You see sine alpha and sine alpha? They are the same thing, huh? Can I just remove from both sides?
Yes.
Yeah? This one and also this one. You see the sine alpha is gone. Then I end up with what? On my last
Cosine
expression.
beta.
1 equal to cosine beta minus. How about the other thing, guys? I have cosine alpha sine beta divided by sine alpha. What's going to happen there? Look at that. Sine beta is a different arc. But alpha and alpha, you see that they are the same thing. That's right. Is it possible at this stage, I divide cosine alpha divided by sine alpha, and based on the common ratios that you learned before that the cosine of an angle divided by its sine ratio, it gives you what ratio? Cosine alpha divided by sine alpha on our first day becomes cotangent, that's right?
Yes.
Then becomes minus cotangent alpha, but these two terms are gone, and I'm left with what? With the sine beta, correct?
Yes.
That's right. Then isn't that the same thing that we wanted to find? That's right. Look at that. That's exactly the same thing that we were looking for to prove. Then you see that even we didn't need to know the knowledge of the fluid mechanics. That was simply a very easy manipulations of the sum of two angles in case if you are looking for it's the sine ratio of them. And now this is proved. We show the identity is valid. Any questions, guys? Hello?
No question.
Nobody has a question?
No.
Okay, how about Philip and Ferris?
No.
Okay, nice. Then now, guys, that's the time to move to the second question. Okay. Okay, I think we can just work on 2. Okay, now people who are interested in science today, that's the lucky day for them, because the second example also involves the science. I call that example 2. Guys, in science, I think probably you should have it. I don't know at the high school, but at the university, you're going to get lots of, I should say, circuit analysis, which is for some kind of electronics. In the AC circuit, it's too advanced. We're not going to talk about what is that. We say that sometimes the resistance is defined with this equation. We call that resistance. We do not care what is a resistance in an AC circuit, but we say that the resistance is defined like this. Becomes cosine of S times cosine of T. Oh, the color is horrible. Let me change a different color. T as the time, divided by W, which is the frequency, times C, which represents the capacitance. We do not care about them, into the sine of S plus T, which are, I should say, are variables there. We do not have only X or one variable. That's X. I want to ask you please to show that you can rewrite this expression as R equal to one divided by frequency times capacitance, W times C, into tangent of S plus tangent of T. Okay. Isn't that beautiful? Oh, sorry, maybe you couldn't see that. Can you see it now, guys? I said that the R, which represents the resistance in an AC circuit, is defined as the cosine of the S times cosine of the T, divided by W times C, they are constants, times the sine of S plus T. Show that you can rewrite the R as 1 divided by WC times tangent of the S plus tangent of the theta, tangent of the T. Then essentially, guys, I have to say very warm welcome to the field of electronics. That's your first exposure to electronics in the electrical engineering by using this identity. You do not need to know anything about those concepts, but you are using one formula there. Use the knowledge of the trigonometry to rewrite it by this formula. The best day ever. We see every field, how these equations, they are using it into different fields then. Everybody clear what needs to be done?
Yes.
Awesome. Then I give you, I think 3 minutes should be fine. 5 minutes, huh? Yeah, please give it a try. Do your best, guys. Do your best. I'm sure you can do that. Yes, anybody solve it?
Not yet.
Okay. How about I start and you please help me to finish it, huh? Yes?
Yes.
Everyone is here. Please, guys, say your name if you're still there.
Rose.
Philip.
And no one else? There's only two? Okay.
Gloria.
Gloria. How about Ferris? Okay. Guys, look at this. I'm going to start from the same thing on the top. I'm not going to write W and C because we do not need them. They are constant, and at the end, you can just incorporate them into the equation then. Then R, in that sense, becomes what? R becomes a ratio of, I'm going to write cosine of S times cosine of T, which is divided by, let's say, the sine of S plus T. Okay. The point now here, the point is going to be very simple. And that's going to be that case. Wherever we see the sum of the expressions, we are just going to expand them to write it like what? I'm just going to expand this one. I'm going to, from this expression, come to here and write it like that, that the R has to become what? At the numerator, I cannot change it. I put it as the cosine of the S times cosine of the T. But at the denominator, I can expand sine of S plus T into what is that going to be then if I want to expand it? What is that going to be? No, nobody has an idea?
I as cosine T plus cosine S multiply sine T.
That's right. Plus cosine S, multiply that to sine T. Okay, and that's that thing. I got to this point at this stage by expanding the denominator of that equation to this. And now, guys, you can, when you're at this stage, you can do whatever you want. You can even leave at this point and say, okay, I'm totally fine to keep the cosine of the S, and T represents the time, and cosine of the T there, and the denominator is fine. But the problem is that the task at hand was that to just get to this identity. And I see that the numerator is 1. The question is that now, how can I turn this expression which I got into this expression by having the numerator as 1? What's the strategy? For example, if the numerator was 5, I want to turn it to 1. What should I do? Hello? No idea? Rose, Philip, Ferris?
Mm-hmm.
Can I, if, for example, I say that if the numerator is 5, this is now here cosine S cosine T, I want to change it to 1. What should I do? Should I divide it by itself? For example, this is 5. I want to make it to 1. If I divide 5 by 5, I get 1, correct? That's going to be the strategy. I'm going to then divide the numerator of this term into itself, which is cosine S, cosine T. Does it make sense to Rose, Philip, Gloria, and Ferris?
Yes.
Yes? Okay.
Yes.
Yes.
Awesome. If that's going to be the strategy, I'm going to start from this. I'm going to start from this. Everybody sees the paper or, yeah?
Yes.
Awesome. What was that? The equation I had this one. I have now R equals to okay. I have the numerator as cosine S cosine T, and I divide the numerator by itself, which is cosine S times cosine T. But you know that if you have a ratio, if you divide the numerator by something, you have to do the same thing to the denominator. You know that, huh? Because you are playing a fair game. If you, for example, give something to the numerator, you have to give the same thing to denominator because they become jealous. That's right. That's how I learned it. Then if I divide it, the numerator by this expression, I have to do the exact same thing to denominator, not to make them to be jealous. Then I'm going to do the same thing. What was my denominator before? Was cosine S. I started from the right term. Sine T plus sine S cosine T divided by the same thing, which is cosine S times cosine T. So far, so good. Now, my R turns to what now? I do not need that paper anymore. I can put this aside. Okay. This equation turns out to what? I have R. And now what is happening at the numerator? Cosine is cosine T divided by cosine is cosine T. Can I write it as 1? Because it's divided by itself, right?
Yes.
Right. And how about the denominator? I can expand it. I can look at that. I can divide it into 2 terms in case if you want to see what's happening. I know that the denominator remains the same thing. It becomes cosine S, cosine T, and I have cosine S, cosine T, but I have this one here. It's going to be plus. I have sine S, cosine T, and I have cosine S, sine T. Everyone is okay? Can you see what I have written?
Yes.
Awesome. And now, what's going to happen now? It's equal to what? I have my numerator 1. But the first term, cosine S, sine T, cosine S, cosine T. Look at this one, cosine S and cosine S. They are the same thing, huh?
Yes.
Can I then remove them?
Yes.
Then what I have, then in case I have then sine T over cosine T, which is equivalent to what? The tangent of T, right?
Yes.
Because you know sine divided by cosine of the same angle, it produces to the tangent of the same angle. Then it becomes plus. I have now, look at the second expression. I have sine S, cosine T, cosine S, cosine T. Look at this one. I have cosine T at the numerator and cosine T at the denominator. They can be gone, huh? Because they are the same thing. Then I'm left with what? I'm left with sine S divided by cosine S, correct? Which becomes to what? Tangent of the S, correct? Then essentially, that's the thing which I wanted to prove. I wanted to prove, starts from here to get to this, the W and C, the frequency and capacitance, they are constant. I do not take care of it. But tangent S and tangent T, it can be expanded to this format. And you see, I got the same thing which was expected from me to do that. Any questions, guys?
No.
No? How about Philip?
No.
How about Gloria?
No.
How about Ferris? Okay, seems that Ferris stepped away for a couple of seconds. Okay, guys, then if you have no questions, congratulations to you all. Now you were able, before we go for the break, you were able to use these trigonometric ratios and identities that you learned into two different contexts. One of them was the fluid mechanics, and the other one was, I should say, electronics with the AC circuits. There was no need for knowledge about these two fields, but we saw how the math and how the things that you learn, they can work in a very specific context. One fluid mechanics, one electronics. Then that was very good. And then you see, you feel the knowledge of these things you learn is crucial in any fields in future then. Okay, let's go to take a break. Now this is 12. Guys, today we are going to take one more minute break. It's now 12:09. Imagine this is 12:10. We come back by 10:25. Okay,
Okay.
come back after 15 minutes, 16 minutes for the class. We just start back by 12:25 then. Then enjoy your break, guys. See you soon. Hello guys, are you back? Who is back? Say your name, guys.
Gloria.
Gloria, fantastic. Okay, who else? Just Gloria? How about Philip, Ferris, and Rose? Am I early or this is still the break time? Maybe I'm at 2 minutes early. Okay, everybody's back now? Okay, good.
Yes.
Okay, awesome. Philip is back, Gloria is back. How about Rose and Ferris? Example. Okay, now. Rose is not back yet? Rose. I can see the paper. Okay. Let's get it started. Okay. Guys, please say your name if you are there.
Rose.
Gloria.
Philip.
How about Ferris? Okay. Now, guys, look at that. For the third, we're going to cover 4 examples today before we go home. Actually, we are home before we finish the session. The third one is going to be something that you're going to see that at the first year of your university when you talk about, let's say, the wave mechanics. But we are not going to talk about the waves. Essentially, it's like that. For example, they say that there is a wave, which is, let's say, as a sinusoidal, for example, moving towards the right. They show the wave equation by y1. And also, they show that there is another wave coming to the right, coming to the left, which it becomes with the plus sign there, with the same amplitude, which is going back there. It showed that by the y2. It becomes like that. Probably you will see that in your physics course, physics 12, but before to get there, we see that how the math behind it works. We do not need to know so much knowledge about the wave mechanics and how you represent a wave mathematically. But so far to learn that y1, which is a sine function of kx minus omega t, imagine kx is alpha, omega t is beta. But t here represents the time, x represents the space, and you will see that how a wave, in future you will see that, how the wave equation, I should say, mingles I should say the dimension of the time to the dimension of the space. X is from the space, the Cartesian coordinates, and t is the time. It's a good thing that you're exposed to it right now. You see that the wave equation is actually the combination of the space with time. And also the second thing for the other wave equation, which goes back to the backwards, then this is with the plus sign. Kx, imagine this is alpha, the omega t is this is beta, and a, they call that the amplitude of the wave. It's not necessary to know that, but it means this one is going to be the a. The maximum of the oscillation when it goes on the top to the x-axis, they call that amplitude. We do not need to know that. That's I just want to warm you up to see how the trigonometric function laws and identity is everywhere. We said that we have two wave equation, y1 and y2 with these functions. A is constant, like the WC on the previous one which you talked about, the electronics. You do not need to take care of it because A is constant and it's equal in both ways. It means that this one also, as an amplitude, it's going to be A, the same thing. Then they are the same. They are no different. Then we say that y1 and y2, which represents two waves, they are moving in different direction. You combine them, you add them together. y1 plus y2, which it becomes this one. When you add them together, one comes from the left to right, one waves comes from right to left. They meet at this point that they are summed. They call that standing waves. The wave is stuck there. Now, these are, I should say, maybe too much new knowledge. We do not need that. But the math behind it, that you're going to work with it, is this. Imagine that you have two wave equations, which there are two sine functions which you have learned this term. You're going to add them together. Without any knowledge about the wave mechanics, you're supposed to show that when you add y1 plus y2, you end up with this, which is cosine sine chi x 2 times a. 2 is constant, a is constant, sine of chi x times cosine of omega t. And as I said, imagine kx is alpha, omega t is beta in general case. Then please show this identity. Prove this identity. As I said, you need no knowledge about the mechanics, but you need about the math behind it. Everyone understood what needs to be done? Everyone is clear about that?
Yes.
Awesome, awesome. Then any questions?
No.
If no, please take a couple of minutes to work this out. And please let me know if you have any questions. Okay, are you done?
Yes.
Oh, great. Okay, how about Philip, Ferris, and Gloria? Gloria,
Yes.
are you done?
Not yet.
Not yet. How about Philip?
No.
But you're working on it, huh?
Mm-hmm.
Awesome. And we give it 1 more minute, then we try together then. Okay, let me start a little bit on it. Let's see, what do we get? No, but in the meantime, let me. Okay, I will do that later. Okay, can I just start it?
Yes.
See what happens. Okay, I'm just gonna write the answers here. Then I hope that it should be fine with you all. Okay, guys. Y1 is, as we said, that's a wave equation. But if I just want to expand A into that, what do I get? I can write the A as a constant. What is the sine kx minus omega t if I expand it? Sine kx cosine omega t minus cosine kx sine omega t. Correct?
Yes.
How about the second one? I keep the A there and I expand sine kx plus omega t. What is the expansion of sine kx plus omega t? The same thing becomes sine kx cosine omega t now plus cosine kx sine omega t. Correct, guys? Everyone is so far so good?
Yes.
That's right. Philippe, Gloria, Ferris,
Yes.
everyone is so far good?
Yes.
Then what's going to happen now? Sorry, someone said something? And now when I say that y1 plus y2, it means that I'm just going to add these two sides together. Look at this one. When I add them together, the term which is cosine kx sine omega t and cosine kx sine omega t, they have opposite signs. You see, this is minus, this is plus. Then it means that when I add them, it goes to 0. Correct, Philip? Yes,
Yes.
Philip? Then what I end up with, these two expressions, which they are the same, sine kx cosine omega t and sine kx cosine omega t from y1 and y2. Then becomes two of those terms. Then becomes 2 times, and I had a as a constant of sine kx cosine omega t. And you see that this one matches exactly the same thing which I have there. And they call that in wave mechanics, they call this type of wave function, they call that standing waves, because the energy is blocked into space and it doesn't propagate. It's a very fascinating field to learn. I'm sure that you will like it a lot when you are at in your programs. Okay, any questions, guys?
No.
Nobody has a question? Rose said no. How about Gloria, Philip, and Philip?
No.
No.
No? Okay. Now, I remember somebody said before that they just want to do art. Who said that they just want to do the art?
Me.
It was Gloria, huh?
Yes.
Awesome. And I think also Philip, huh? Okay. And now I have a good question for you, Gloria and Philip. This is about the trigonometry in the art and painting. Okay. Okay. Guys, in the art, this is going to be the very last example that we are exploring to see how these identities, they are working in industry. Now we are going to the art. In the art, we have the concept, which is called the two-point geometry, two-point geometric perspective in the art. And they said that by using that geometry, that shows that the way which you have to scale your, I should say, for example, you imagine 2 points A and B. For example, imagine that you are drawing a vase. There's a point between those two A and B, but you have to scale it down into your canvas to make it smaller in order to fit that on your canvas. And in order to just do the scaling properly, there is a math equation which is very interesting. And the math equation behind it is this. It says that the difference between point A and point B, it's going to be the tangent of the alpha. Alpha is the angle between these 2 points. If we just connect these 2 points together with respect to the horizon, then it becomes tangent of 90 minus alpha. We want to show that. I can write this one as A over B equals to the tangent squared of alpha. Now we are just in the art and painting. We are talking about the two-point geometric perspective. We say that the ratio of the two, I should say the distance of 2 points A with respect to the B, is tangent alpha divided by tangent 90 minus alpha. We want to see that if we can just rewrite the same expression with this identity. Give it a couple of minutes. Okay, who's done now? Rose, Gloria, Philip?
Not
Mary?
yet.
Not yet. I think Gloria should be very excited today because she's going to just go for the art major and now we have something in the art. Gloria, are you excited for it?
Mm, yes.
Okay. Okay, now I'm just going to start it and you please help me in the midway. Okay. In order to start, I want to remind you of two things. I'm just going to write it at the back of the paper. And that fact was a fact that I told you when we talked about the sine of the sum of two angles and the cosine of the sum or difference of two angles. I asked you as a homework to just find the tangent of the sum of the angles, which essentially it becomes this. We say that the tangent of, let me use a different color, which essentially it means that we talk about the tangent, let's say, of alpha plus beta. Who proved that identity? Who did that homework?
Is equal to tangent alpha plus tangent beta over minus tangent alpha multiplied tangent beta.
Oh my God, that is super impressive. Thanks. It becomes then tangent, thanks Rose, tangent alpha plus tangent beta, and it becomes what here? Becomes 1 minus, look at that one, minus tangent alpha to tangent beta. Guys, look at this one. This is super crucial. This is the plus sign between, I have minus there. Then as a result, I can write the same equation. I say the tangent of alpha minus beta, the tangent of the difference of an angle. What is that going to become?
Tangent alpha minus tangent beta and over 1 plus tangent alpha multiplied tangent beta.
Fantastic. Thank you very much, Rose. Very impressive. Becomes 1 plus tangent alpha, tangent beta. Guys, look at that. With these two identities, we see that, look at that. If we have a sum, the tangent of sum of the angles, the numerator is summed, but 1 is minus. But if they are subtracted, the same thing happens there, but they are plus when they are getting multiplied. That's right. That's what we talked before. And also you had it as a homework to prove that. The proof was very easy as long as we know the sine and cosine of the sum or difference of the angles. Any questions of these equations?
No.
No? Okay. And if there is no question, we are just going to go to this one, to the main equation. Who solved this one?
Not yet.
Okay, guys, I'm just going to give you 1 or 2 more minutes based on these two identities, which I proved that I showed that to you. Give it a try once more to see that if you can finish that exercise. I think 1 more minute should be fine then. Huh?
Yes.
I'm going to keep this one here. You can use these ones, these two, especially number 2, to try to use this one. I'm going to show this one here in case if you need this. I give you 1 more minute then in case if you were working and now you know the identity. Okay. Let's see. Rose, are you done?
No.
How about Philip and Gloria?
Not yet.
Not yet. Okay. Let me start working on it. Then you please help me at different stages then. Okay.
Yes.
Okay. Now, I'm just going to start from this. I'm going to start right away from this identity, which I have on the top. I bring it here right from there. I think that color is not a good one. Probably you won't see that. Let me choose my color. Change the color to this one. Okay, now I write here what? I write A divided by the B equals to, I have tangent alpha there, but for this one, tangent 90 minus alpha, I'm going to expand it to the identity which we learned about the tangent of the alpha. Which essentially it was what? Essentially it was, becomes the sum, becomes tangent 90 minus tangent alpha divided by, because this is minus, it becomes 1 plus tangent 90 times tangent alpha. Correct? I didn't do anything except the fact that I tried to, I should say, I tried to use this second identity to work on this one. Okay. Then as a result, let's see what happens there. Everything is going to happen at this ratio. Every important information is going to be taken from this denominator of this ratio. Then forget about the tangent of the alpha at the numerator. We focus at the denominator. And now we have two angles there. What are my angles here? One is alpha, the other one is 90. Alpha is a mysterious angle. It's like the Zorro, the legends of the Zorro. We have no idea what is the alpha, But for the tangent of the 90, it's something crystal clear for us. 90 is a known, well-recognized, well-identified angle. Then, as a result, its trigonometric ratio should be clear. Okay, guys, what is the tangent of the 90?
No existence.
Sorry, what?
Tangent 90. No existence.
It is what, sir? I can't hear you.
It's 1/0.
That you mean it's not defined, huh?
Yes.
For the tangent?
Tangent 90.
That's right. Then we see that, okay, then in that case, the problem which we would get is that then it's not going to be a defined angle. Then the problem is that this expression is not going to work. Then because if I just put it here, tangent 90 becomes, they call that becomes infinity, and the infinity is not going to work. Then this method, if I call this method number A, for method number A is not an acceptable method, then I'm just going to put this, I should say, a cross on it, because it means that with this method, I get with something which is not well defined. But I did that on purpose, that in case if you know the tangent of the sum of the angles, you show that you do not use that, because with the tangent of the 90, you end up to nowhere. But I have a better idea on how to do that. What's the best strategy to solve this? I come here and I say that, okay, as long as I cannot use, give me a second, I open the window and I come back. Okay, I needed some fresh air. Okay, I said that, okay, as long as I cannot use that identity, let me divide and decompose whatever I have on the right side into what? Into the sine and cosine. I say that in that case, I mean, I do this by doing this. I say that the A divided by B, instead of writing it as the tangent alpha, I'm going to write it as what? For tangent alpha, I'm going to write it as sine alpha divided by cosine alpha, or still you could do that, still you can write it as a tangent of the alpha. And here also, I can write it as what? I can write it as sine 90 minus alpha divided by cosine of 90 minus alpha. Okay? Everyone is good?
Yes.
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 And now, guys, you have two options right now to do. The first one is that you can expand the sign of 90 minus alpha, write it as in sine alpha, cosine beta, sine 90, cosine alpha, minus cosine alpha, sine alpha. Or you learned it previously that this kind of stuff becomes like what? Becomes like the complementary of angles in a triangle. If you remember previously, we also proved that to you that, let me write it here still, let me write it as, it becomes sine alpha divided by cosine alpha. And what we learned before was this. We said that for these angles, we call that complementary angles. We said that in a triangle, you remember that? We said that if we have a triangle, I'm going to show that here to you, that you remember what we did. If this is going to be, let's say, That's a right triangle. Everyone can see that?
Yes.
If this is alpha, how much is this angle is going to be?
90 minus alpha.
That's right, 90 minus alpha. You proved that before, that in a triangle, which is this, the sine of alpha, the sine of this angle is the cosine of this angle, right?
Yes.
And the cosine of this one is the sine, cosine is, you see that this is complement, it was a crossing relationship between them. We said that the sine of this angle is equal to the cosine of the other angle, or the sine of this angle is equal to the cosine of this angle. Then here, the sine of 90 minus alpha is essentially based on this become cosine of the alpha, right? And the cosine of 90 minus alpha becomes the sine of the alpha. You got what happened?
Yes.
Also, if you want to prove that, if you do not want to use the right triangle, you can expand the sine of 90 minus alpha into sine 90 cosine alpha, and you see that the cosine 90 becomes 0, and you get the right expression. You get the same results if you expand these ones based on the sum of the angles. Okay. And now what's going to happen here? We have sine alpha, cosine alpha. It equals to what? Sine alpha, cosine alpha, multiplied to what? To the expression which we get. It has to be what? You reverse it when it comes to the top. Becomes sine alpha, cosine alpha. It essentially becomes what? You multiply them together, becomes what? Sine alpha times sine alpha. What do you get? Sine squared of the alpha. Cosine alpha times cosine alpha. What do you get? Cosine squared of the alpha, which is essentially what? Tangent squared of the alpha. Right?
Yes.
Everybody got what happened?
Yes.
How about Rose said yes, huh?
Yes.
How about Gloria?
Yes.
How about Philip? Philip is gone. And Ferris, the mystery man. Seems that he stepped away then. Okay. Now, if you guys, no questions. Do you have any questions for today?
No.
No? Okay, guys. Then I have to tell you today that we just, before we just wrap up the lesson and finish the course, then today, as you noticed that we worked on 4 different areas. We just worked with, I should say, in the fluid mechanics. Then we did electronics. Then we did, I should say, wave mechanics. And now even just worked eventually with the art, with the 2-point geometric perspective. We saw that the trigonometric ratio that you learned and the identities that you're learning, it's everywhere in every discipline. How do you feel today? Excited?
Yes.
Super, super. Then if you have no questions, I see you all tomorrow. And always remember, if you have any questions weekdays, just post that on the Schoology website then. Okay?
Okay.
Awesome. If you have no questions, we finished the class today and I see you all tomorrow. Any questions, guys?
No.
No? Then have a very nice day and I see you all tomorrow then. Bye, Gloria. Bye, Phil. Bye, Rose.
Bye.
Bye, Ferris.
Bye. See you tomorrow.
See you tomorrow, Rose. Take care. And Rose, by the way, are you there still?
Yes.
Oh, just by the way, I forgot to tell you, do you remember on that day that we had Professor Zhu, Hongmei Zhu, and you were in that session present, and she was talking about the modeling contest from grade 9 to 12.
Yes.
Your math is very strong. I think you need to just participate in that. This is working at home. Then you pair with one of my students at the function 12. He's also very strong like you. I think you have a good chance to win the competition.
Okay. I worry about, is it too hard for me?
No, it's not too hard, and I can also help you in the group. If you had any questions, I help you to just solve the question. But it's a very easy. But that's a good thing that I think I recommend you to take part in that competition. Is it fine?
Yes, sure.
Yeah, because your math is very strong. I'm sure you can do an exceptional job there.
Okay.
Awesome. And it's good also when you apply to universities, it's a good thing on your resume.
Okay. Yes.
Awesome. Then I give you more information about when is that. And if you have no questions, then I see you tomorrow, Rose.
Okay. Goodbye.
Awesome. Thank you, Rose. See you tomorrow. Take care.
Okay, see you.
Bye-bye. See you later. Bye. Okay, let me finish this. Ferris, are you there?